Now, throughout the previous lectures, we were building a keylogger, and we tested it in the previous lecture and it was working perfectly. Now all we have to do is just implement a sendMail or a method to write the logs to a file in here instead of printing the logs on screen, and the code is done. The problem is, as you can see, the code is very ugly. We're using a global variable called log, and then if we use the sendMail in here, we're gonna have to define two new global variables, which is the username and the password for the email. Because as you remember, if I go to my send email code, you can see that when we call the function, we have to pass a username and a password. Now, because of the way the listener works and all of that, similar to the reason why we have to use a log in here, a log variable, we'll have to define the username and password in here. Furthermore, if we wanted to set the time interval to a variable instead of keeping it hard-coded in our code in here, we'll have to add another variable in here on top. So this is all not really good practices when it comes to programming, and it also gives me a great opportunity to introduce you to object-oriented programming and to Python classes. Now, the reasons that I just mentioned are not the only reasons that why you might want to use classes, but this program is a really good example to show you classes in practice instead of me just talking about classes and show you a useless program that uses classes. So, before we start writing code, let's talk about classes really quick. So basically, classes in Python allow us to write object-oriented code, and this is where the whole idea of object-oriented programming comes from. It's a method of modeling or writing your code. All the programs that we wrote before, we can write them as classes, as objects. The reason why I didn't do it, because they were simple programs, and even the ones that were a little bit more complicated, it just made sense to use them simply as functions. But sometimes, and usually when the code gets more complex, or in some instances like the instance that we have right now, it really makes sense to divide the code or write it as a class. So it's like a blueprint of how the code is going to be used. Now you'll see once we put this in practice, our code is going to be more readable, it's going to be more reusable. So it's similar to the way functions make our code more reusable, classes will make it even more reusable. It's going to separate the implementation from the usage, so we'll be writing the class and then forget about how it works and then just use it from the program, and you'll see how that's going to work. Now, because of all of these good things, because of the way it works, because of it's going to be more readable and more reusable, our code is going to be easier to extend, so it'll be easier to build up upon, and it'll be easier to maintain and fix issues if there were any issues discovered later on. So, enough with the talking, let's go and put this in practice, and I think you'll get a better idea of what I'm talking about. Now, I'm actually going to convert this program right here into a class. The first class that I'm going to write throughout this lecture is actually not going to be great. It's going to be a really bad class. But I just want to show you the transition between writing a code like the way we were writing it and how to just convert it to a class. You'll see it's actually very similar. So the first thing that you need to do when you're defining a class, so in order to define a function, we say def followed by the function name. Now, if you want to define a class, you're gonna say class followed by the class name. And as a common practice in Python, when we define functions and variables, we always use small letters, and if we're using more than one word in the variable or function name, we use underscores. This is different when it comes to classes, and it's just a way so that people know when they're programming whether they're dealing with a class or with a function or a variable. So you can actually call the class anything that you want, but if you want to follow the common practice, then you should call it something that starts with a capital letter. Now, since we're building a keylogger, we're going to call it Keylogger with a capital K. Now that's done. Next thing is we're going to put a colon, and then if you hit enter, you'll see that Python will automatically indent my cursor, and then anything that I'm going to write in here is going to be part of my class that is called Keylogger. So it's similar to the way we define blocks of codes in functions, in if statements, and so on. Now, everything that I wrote so far, I want it to be part of my class. So I'm going to highlight all of this and just press tab from my keyboard, and that's going to make all of this part of my Keylogger class. Now you can see that we're using normal functions inside this class, but functions inside classes are called methods. So it's exactly the same concept, but we call this now a method since it's a function inside a class. The reason why they're called methods is because we invoke this method on the class once we create an object of this class. And this will become clearer once we actually go ahead and create and use an object of this class. Now, we've actually been using objects a lot throughout our code, and something that I just noticed right here, we're using an object in here. So we're basically saying the timer, which is a variable, is of type timer with a capital T. So you can see that this is a name of a class because remember, like I said, when in Python, when we create classes, we call them a name that starts with a capital letter. So basically what we're saying is my timer is a variable of type timer. So timer here is an object that is defined in a class called timer. And then we're calling the start method. So we're saying timer.start because this is just a method inside the timer class. So it's similar to the way we have the process key here. This is a method. The report here is another method that can be invoked on our Keylogger class or on the Keylogger object once we actually create it in a similar syntax like this one. Now, because these methods like the report and the process key will be invoked on an object once the object is created, we're going to have to put self as the first argument in this method. So every method that we define inside the class, the first argument has to be self because this method will be called on an instance of this object. And I'll revisit all of this once we actually create an object of type Keylogger. So I have to do the same with my report method. I have to put self as an argument. And I also want to put all of the code in here because remember, this code was just put so that it actually uses the above two methods and starts my Keylogger. Now, because this is going to be a class or an object, this should be put inside the method. So we're going to create a method called start. And again, as you can see, once I open a bracket, PyCharm automatically puts self inside this bracket. And then I'm just going to tab all of this code so that I can do keylogger.start, and that will start my Keylogger. Now, another note when using classes, every time you need to use a variable or a method that is defined within this class, within the class that we're using right now, you have to put self before the method name. For example, in here, we call the report, which is this function right here. Now, usually we just type report and this will know that this will call that. But since this is in a class and we're calling a method that is defined within our current class, we're going to have to say, I want to call self.report. So I want to call the report method that is defined within this class. And I misspelled self in here, hence the error. And I need to do this the same everywhere that I call a method that is defined in my class. So I need to add self before this. And I also need to add it in here before the report. So we're saying I want to call self.report, which is again a method that's defined within this class. So now everything is done. All we did is we created a class by saying class followed by the class name, first letter, capital letter. We had to pass self to each method that is used in our class. each function now is called a method, not a function, because it gets invoked on our class. And every time we use a method that is defined within our class, we had to type self before the name of that method. Now we're done, and let's use this class. Now we created this class right now, and even the start method, or the way that we used to start our program, which was this piece of code in here, we put that inside the method. So now if we literally just call keylogger.py, nothing is gonna happen. So let me show you. So if we just do Python keylogger.py, you'll see that nothing happens because we're creating a class, we're creating a blueprint of the keylogger class, of something, of an object that is called the keylogger, but we never actually used this blueprint to build the object. And this is where you see the first really cool thing about using classes. So in order to use this class, we have to create an object that uses this blueprint or uses this code to work. Now, you can do that in here, but that's not a good practice. A better way of doing it is creating another Python file. And this file is actually going to be the file that uses this object and runs our keylogger. So this is the file that you'll name as your program name. So for example, I'm going to call this zlogger.py. And then in here, first of all, I'm going to add the shebang. And then we're going to say import the file name that we have in here where we defined our class. So it's called keylogger with a small k. And then we can say my keylogger is equal to keylogger, which is the name of our file where our class is defined, dot keylogger with a capital K. So this is going to create my object based on the class that I defined in here, because I'm calling this class right here. So what I'm doing in here, I'm basically creating a new object. I'm storing that in a variable called my keylogger, and this object is going to work using the code that is defined in my class, which is called keylogger. So now, in order to start my keylogger, all we're going to do is my keylogger.start. And this is what I meant why we call these methods, because right now, if you remember, when we used to call functions, we used to just call the function like so. So we just type the function name like this. But because this is a method defined inside the class, and we created an instance of this class first, and then we're calling start. So basically we're saying that we want to invoke the start method on my object that I just created, which will derive its code, or its code is going to be based on the blueprint that is designed or written in here. So if you look at the code in here, you can see that whenever someone needs to use the keylogger class in the future, they don't need to know the code used inside this class. They don't need to know how the programmer wrote this class. They can just import keylogger and start the keylogger by saying my keylogger.start. That's all they need to do. The programmer might come in the future, update the code in here, change the code, modify it, add more features. Whoever is using this in here doesn't really matter. They don't care about the implementation of the code. They are just using it in here, and then they can focus on the code that they are writing. So this is one of many advantages of using object-oriented programming or using classes. Again, the code in here is still not very pretty and still has a number of bad practices that we'll fix in the future. But for now, let's just test this and make sure that it still works. So if I just go Python zlogger.py and start writing some stuff in here. So let's say this is a test. And you can see that it recorded this is a, and test should come up in the next iteration. As you can see, let's write something else. Again, something else comes up, and then everything is going to be cleared on the next one. And perfect. So it's working perfectly, exactly the same way that our previous code was working. And in the next lecture, I'll show you how we can actually improve this code, because like I said, there is still a lot of bad practices in here, and there's still a few things that I want to cover when it comes to classes and object-oriented programming.